Okay, so now that we've looked at the standard normal and the table idea, we want to talk about z-score. So I can, because the normal distribution is always in terms of, or you can put it just in terms of the mean and number of standard deviations away from the mean, then we can turn everything into z-score. And one, to me, as I think of z-score, I'm just changing units. Okay, to me, that's all I'm doing. So, you know, if I have something that is, you know, suppose I have a data, you know, a data point of an average, you know, X bar is, you know, 64 inches. Okay, so I've done this, and what I understand from this is, you know, from working on this and so forth is, you know, also my best guess for the standard deviation of this, or well, let's go with standard error. The standard error in this particular situation is, you know, maybe 4 inches. Okay. Now, if you tell me that I have some data that oh yeah, I didn't want to use X bar there. I want to use mu. Sorry. So that's the population mean is 64 inches, and the standard error for what I'm doing, we'll say, is 4 inches. Then, you know, say I have some data X bar and equals 68 inches. And what I would like to know is maybe what's the probability that X bar, when I do this, is greater than or equal to that 68. So the picture I'm talking about here is that here's 64, here's 68, and I would like to know how much of the population is over there. So if that's the kind of thing I'm asking, well, you know, the answer is, well, gee, I don't know. Except, yes, I do, because what I can do is turn this into standard deviations instead of inches. Okay, so if I want to know how many standard deviations away I am, hopefully I've picked nice numbers that you can see, oh, that from here to here is 1 standard error. Right? 64 plus 4 is 68. I went 1 standard error over. Oh, well then all I have to do is look up in my table, my z table, what's the probability that z is greater than or equal to 1? And I know that that is about, let's see, so it's, right, you've got 50% here. You got another 34% there because of the rule of thumb, and so that's 84%. So I know this is about 0.16. Okay, I can look it up in the table and check, but what I should find is that in the table, the probability that z is less than or equal to 1 should be about 0.84, and then to get this probability that is greater than or equal to, I take 1 minus the probability that z is less than or equal to 1, and I get 1 minus 0.84, which is 0.16. Okay, so I can use my table, look up the area to the left. I should get about 0.84, and so I take 1 minus that, I get my 0.16. Now, well, how did I know that was one standard error? What did I do? Well, here's the thing with math is, why is math hard? Because we make you actually think about what you just did, right? It's like we're punishing you or saying, hey, think about what you just did, right? It seems like we're being mean, but that is what math does. It pretty much, we ask, well, how do we know what we know? How did we know that was one standard error? Well, what we did was we took our data, x bar, minus mu, over the sides of the standard error, right? We found that difference. We saw the difference between our data and our mean, our hypothesized population mean of 64. We found that was 4, but we know the standard error was 4, and so that gave us one standard error. Okay, and so if I gave you different data, so suppose instead we had mu was 68, our standard error was 4, but this time we do x bar and we get like 69.5. Well, then let me put z equals here, because z is our number of standard errors or standard deviations. So z is equal to our 69.5 minus 68. Oops, not 6. Wait, mean was, wait a minute. Mean was 64. Try that again. Mean was 64. 64 over 4. And so this is 5.5 divided by 4. And that is whatever the heck that is. That's not quite 1.4, so 1.32575, I don't know, something like that. And so we get that, and I could look up a probability associated with that. Okay, if the number were negative, so mu is 64, standard error is 4, and say x bar is less than that, and so we're down here at maybe 57. Then we would have our z is 57 minus 64 over 4. So that's what, negative 7 over 4. So negative 7/4, or negative 1.75. And there we go. That's our z value. I can now go look something up in the table based on that z. But all we're doing is changing the units. We're saying instead of inches, instead of talking about inches, let's talk about these standard errors, the number of standard errors, and that's all we've done. And, and if you think about that, you knew how to do that. And that's, I tend to point that out both as a familiarity thing, like, hey, look, you know how to do this. See, it's just this. But I also point it out as, hey, you don't have an excuse to act like this is something you've never heard of, okay? Because it is something you've heard of. This idea of changing units you've done, and that's all we're doing. We're saying, hey, okay, I went from 64 to 68. I jumped up 4 inches. Great. Oh, but what if I said, well, I didn't want 4 inches, I wanted it in feet. Oh, well, then that's 1/3 of a foot. Okay, or what if I wanted it in centimeters? Oh, crap, 2.54 centimeters in an inch, so 4 inches times 2.54, yeah, it's about 10 centimeters. Okay, so that I'm just changing units. But here, the units have to do a standard error, so I find that difference. I've got the 4-inch difference in this first case, but the standard error is 4 inches. 4 divided by 4 is 1. Okay, then in the next case, I had a difference of 5.5. Oh, but there's 4 inches in a given standard error, and so 5.5 divided by that 4 is 1.375, or at least I think it is. And same down here. Okay, I dropped from 64 to 57. Okay, I dropped a total of 7 inches. Okay, but I don't want inches, I want standard errors, so 7 inches divided by 4 inches, I get 1.75, but it was negative, so negative 1.75. And there you go. All I'm doing is changing units just like you would change from feet to inches or yards to miles or something like that, and using the standard error amount or standard deviation to change those units. Okay, and that's all we're doing when we go to a z value. Okay, so we'll call that done.